Good afternoon, or morning as the case may be, and welcome to Turning IT Innovations into Your Video Surveillance Advantage, sponsored by Pivot3. I'm Scott Goldfein, Editor-in-Chief and Associate Publisher of Security Sales and Integration. I thank you for joining us for what promises to be an informative and productive hour. Here's a brief description of our topic today. Improvements in video surveillance technology are putting unprecedented demands on traditional infrastructure. Experts predict that by 2017, IP video surveillance cameras will generate more than 1,500 petabytes of new data every day, or more than triple the rate in 2014. So it's essential security integrators educate themselves and devise effective strategies to optimize systems such that they meet this escalating video management challenge. Fortunately, there are advanced surveillance and infrastructure solutions available to help lower costs, reduce risk, and protect critical security investments. That sets the stage for this hour-long presentation, in which you'll learn why software-defined storage area networks, or SAN storage, is the best choice for IP video surveillance. You'll also learn how to virtualize recording servers to vastly improve system resiliency and performance. And you'll learn how to virtualize client workstations to reduce costs and mobilize fully integrated systems. If you're a security integrator or other industry professional working in the enterprise video surveillance system space today, you've come to the right place for technology insights and success tips. But before we fully get rolling, there are a few housekeeping matters. As far as listening to this online event, the audio portion is broadcast over the internet. To listen, make sure your computer or device's audio is available, unmuted, and the volume is turned up to an acceptable level. If you're having trouble with receiving this audio, please select the question mark in the upper corner of the TalkPoint interface and select Test My System Now. This will give you information on your connection and how to remedy any problems you may have. And you can participate by asking questions. It's easy to submit them during the event. On the left side of your screen, there's a box labeled Ask a Question, where you can enter those questions. Questions related to the webcast topic will be held and answered during the Q&A session at the end of the event, so stick around for that. Questions related to technical issues can also be entered in this box and will be answered immediately by our webcast producers. We're very fortunate today to have Brandon Reich, Senior Director of Surveillance Solutions for Pivot3, as our main presenter. Having joined Pivot3 in October 2014, Brandon is a technology evangelist, solutions marketing and strategy leader for the pioneer of Hyper-Converged server and storage infrastructure. He is responsible for driving surveillance solutions product strategy and sales and marketing initiatives with highly differentiated solutions for enterprise security and IT customer segments. Brandon's prior experience includes strategic and channel marketing for Honeywell Security Group and Aegis Security Design and Trans Systems. Brandon, thank you so much for joining us today.
Okay, thank you, Scott, and thank you everyone for joining today. As Scott mentioned, my name is Brandon Reich. I'm the Senior Director of Surveillance Solutions for Pivot3. We're going to spend a little time today talking about how trends in both video surveillance and IT are influencing each other. And we'll start out a little bit with an overview of what's happening in the world of video surveillance and how that's influencing IT, and then look at the vice versa of that. And we're going to really focus on educating you on what is happening in the world of IT, and what some of the new mega trends are, and how it affects you in your day-to-day business. And finally, we're going to arm you with some information that you'll need to better compete in a very IT and increasingly IT-driven industry that we all know is happening out there. So let's start out by talking a little bit about what's happening with video. The amount of data being generated by IP video systems is increasing to really staggering proportions. We're seeing higher and higher resolution cameras coming to market. We're seeing new use cases for those cameras, such as body-worn cameras, video analytics, mobile devices, et cetera, and we're seeing the need for longer and longer retention time of our recorded video. All of this is happening while the prices of those cameras are coming down. So suddenly, on relatively fixed budgets, our end users are able to deploy more and more cameras, which are all generating more and more data simultaneously. And the result of this is that IHS is actually forecasting the amount of data that will be generated by IP video systems to exceed 1,500 petabytes of data every single day in 2017, just next year. And that is 3 times the amount of data that was being generated by these same systems in 2014, just 2 years ago. So we're seeing huge growth in video surveillance data. Another organization has come out and said that 50% of the data being generated by the Internet of Things will come from video surveillance in 2020. And we all know that the Internet of Things is one of the hottest trends in the world of technology today. So not only are we generating huge amounts of data, but that data is more and more important to us than ever before. And this has some implications for us. This means we absolutely, our end users absolutely cannot tolerate things like data loss, like downtime, or the inability to access either live or recorded video. This has significant implications to them, into their businesses and their organizations on a daily basis. But believe it or not, because of some of these technological changes, we're actually more susceptible to these type of failures than we ever have been before. Now, as the amount and the importance of this data grows substantially, ownership of these systems, or at least the server and storage infrastructure, is transitioning more and more from the security departments into the IT departments. And if you haven't seen this yet with your end users, you certainly will. We believe this transition is in process right now. Maybe hasn't completed yet. Maybe you don't see it in every single implementation, but you're going to see it more and more as the months and years go on. So you need to understand what's important to the IT world, and you need to be able to speak their language. And of course, you also now need to be able to educate them about things that are important in the world of video surveillance. So when I talk to IT end users, I usually start by teaching them a little bit about why video surveillance is different than virtually any other workload inside of their data center. And there's a couple of things that we highlight as we go through this. First of all, traditional IT workloads, this can be anything like an email server or a web server or a financial system or a database or whatever it might be. Traditional workloads are, rule of thumb, roughly 80% read transactions and 20% write, meaning 80% of the time we're reading data from a disk and 20% of the time we're writing it. Video surveillance is the exact opposite of that. In fact, we say roughly 99% of the time we're actually writing data, large amounts of data to a disk, and a small fraction of the time are we actually accessing or reading that data from a disk. Video surveillance is also a very bandwidth and CPU intensive application. It's very, very different, very challenging. And anyone that has a mobile device understands the challenges around delivering video over a network or to any type of endpoint device. Video surveillance is also a highly variable workload. And what I mean by that is demonstrated in the chart on the right-hand side of the screen here. The green line represents the bit rate or the amount of data being generated by a typical IP camera, or maybe a series or a group of cameras. And what you'll notice about this is that we go along usually at a relatively low number, a low rate, until something happens. And that something happen could be motion inside of the scene, or it could be an alarm, or it could be a classroom letting out, or it could be any number of things. But something happens that causes the amount of data being generated by those cameras to spike. And in fact, it spikes significantly. It can spike by multiple orders of magnitude here. The challenge is because traditional server and storage infrastructure is optimized for this 80% read, 20% write ratio, every single system has to be designed for some maximum level of data ingest, or the maximum level to capture or store a certain amount of data. And if we exceed If our cameras generate more data and we exceed that maximum level of data ingest, the result is dropped video or lost data. Now this is important to understand what happens here, because most people will say, well, if I've got 30 frames per second of video that's being generated and I drop a frame here or there, that's no big deal. Well, it actually is a big deal. And everyone here probably knows about H.264, and that's the compression algorithm that we use to make video more efficient to be deployed on a network or to be stored on a disk. But because of that algorithm, what it means is these frames of video, which are represented here by the blue and red rectangles, are actually dependent on one another. And if we drop data or if we drop frames, it actually has a domino effect and can go through and cause problems with the entire segment of video. And that can cause one of two things. Number one, it can result in the entire segment of video being lost. Or it can result in the quality of the image actually being degraded. And if you understand H.264, you'll know that the only type of data that's actually being transmitted over a network is what's changing inside of the image. In this particular example, what you see is a truck driving through a scene, and you see that the license plate is actually blurred out because we can't read it because for whatever reason our storage system is not able to capture that data accurately. Now, if I'm a security director, if I'm an IT director, I look at this and I say, I've just invested all this money in these high-resolution, super advanced, multi-megapixel surveillance system, and this is the result that I get. I'm going to immediately say I'm not getting the value for my money. In addition to performance issues that lead to drop video, other traditional solutions that IT will tend to lean on for things like mobility, for data and system resiliency, for the most part are ineffective. Things like backup, replication, snapshots, high availability solutions, all of these things, number one, are very expensive, but when it comes to the video surveillance workload, they're really impractical, and in some cases, they don't work at all. So the IT departments now are looking to you as the security technology expert to help them protect their businesses against risks associated with these types of things. But believe it or not, the vast majority of video surveillance infrastructure that we recommend as an industry, for the most part, is really not prepared to protect us against many of these vulnerabilities. So most of us are familiar with NVRs. This is what we refer to as direct attached storage, or DAS, in the storage world. And these NVRs or DAS-based solutions really were designed to function and to create an experience just like a VCR, because that's a model that our industry really understood and was familiar with as we transitioned from analog to digital camera technology. But believe it or not, this architecture is vastly inferior to more modern server and storage infrastructure, and it's highly prone or susceptible to single points of failure, which can result in all of the things that we said before that we cannot tolerate. Data loss, downtime, the inability to access both live and recorded video. What's more, NVRs or direct attached storage-based solutions tend to work okay. They're really optimized for up to 30 to 40 cameras or so, depending on any number of criteria built in. But as these systems get larger and get beyond that, they're more and more prone now to poor performance and to inefficiencies, such as something that we call stranded capacity. Right? And you'll notice here with the image on the right-hand side, we're demonstrating this stranded capacity where you really have 3 NVRs just sitting next to each other, maybe a video management software that makes them look like they're working together. But you never really know where all that data is coming from. So the result of that is inefficient utilization of the storage that was purchased and installed, or potentially the need to always design for the worst case to protect against these types of things. So IT departments have recognized this outside of security, and they've really moved away from direct attached storage in their data centers a long time ago. They've moved towards more of a separate virtualized server and shared storage infrastructure. And this type of architecture solves a lot of the problems of direct attached storage, but it's really an enterprise class architecture, and it's fine for very large environments that have, or very large organizations that have lots of money, that have lots of highly trained IT resources on staff. But generally, this type of solution can be pretty unattainable. It's extremely expensive. It's extremely complex to deploy and to manage. It's built on highly proprietary hardware. And most importantly, SAN, or Storage Area Network, shared storage solutions, are designed and built for general purpose IT workloads that we talked about before with that 80% read and 20% write ratio, and tend to perform very poorly for video surveillance workloads. This leads to data loss and other types of problems like that. So before I tell you how Pivot3 has solved some of these problems, you need to understand a little bit about what IT departments are thinking about every single day. Their businesses or their organizations are directing them constantly to do more with less. So these enterprise imperatives you see on the left-hand side, their job is to manage risk in the organization, to ensure their organization is delivering the services that they need to, and to do this all with ever-shrinking budgets on an annual basis. So they're looking towards these mega trends that you see on the right-hand side to help them deliver these services. They're looking at things like cloud, like mobility, like flash, and even something new called hyper-converged infrastructure, which I'm going to talk about more here in a few minutes. But ultimately, what all of this is leading to is the emergence of this thing that's generally referred to as the software-defined data center. Now, going forward, whenever I use the term software-defined, what I mean by that is recreating the functionality of highly proprietary specialized hardware through software using standard commodity-based hardware. That's the concept of software-defined, and we're going to talk about that a little bit more here as we go forward. So let's first look at the storage industry. The software-defined data center really starts with software-defined storage. Now this is really a huge industry, and for some reason that line's not showing up in the middle, but this is an industry of roughly $35 billion that's expected to double or so over the next decade. And it's really dominated by a few very familiar names that you've probably seen before. Now what's interesting here is that the traditional storage industry, what you see there in orange at the bottom, is really even beyond the stage of maturity, and it's into the decline stage. And that decline stage is rapidly increasing because of the emergence of the concept of software-defined storage, which is represented here in blue. You'll see that these software-defined storage solutions not only are going to become a huge part of the marketplace, this is the IT data center enterprise storage marketplace going forward, but really are being led by a different group of companies and a different group of players here that are really driving us out into this new paradigm that we see in the world of storage. Now once we go beyond software-defined storage, we then move into the latest mega trend, which is called hyper-converged infrastructure. And hyper-converged infrastructure is just really a fancy term that builds on top of software-defined storage and now adds in virtualized application servers. all of this now delivered on standard off-the-shelf commodity hardware. Now I'm going to describe what this means and how this works in a little more detail here in just a couple of minutes. But just so you know, the benefit of hyper-converged infrastructure to the end user is significantly lower cost and complexity from versus traditional data center architecture, and virtually unlimited scalability. So the concept of hyper-converged infrastructure is a mega trend in the world of IT data center infrastructure technology. So why do I tell you all this? Why do you care? As a security systems integrator, why is this important to you? Well, if you are not today a trusted advisor and partner to your customers' IT departments, you run the risk of losing their business, or maybe in some cases never gaining their business in the first place. Maybe you still get a chance to provide cameras and video management software and some services, but you're potentially losing out on a big portion of the opportunity with most of these physical and electronic security implementations. Now, this opportunity that you're losing out on is more and more being delivered or being provided by the IT departments themselves. And they often prefer to buy from very familiar sources, from very familiar channels that they're used to and they're comfortable with. The problem with this, one of the problems, not only is that you lose out on business, but your customers, these end users, may end up installing infrastructure solutions that are really ineffective for all the reasons that I just told you about, and then potentially point the blame back to you as to why this isn't working. So solving these problems is really an opportunity for you to differentiate from your competition, to drive more business with your end user customers going forward, and of course then to become a more trusted advisor and a partner to your end users. So let's take a look now at how Pivot3 helps you do that. So just a little bit of quick background on Pivot3, who we are and what we do. We provide hyper-converged solutions now, primarily for the world of IP video surveillance. Our company was actually founded on the basis of solving a very challenging storage problem with video surveillance back in 2002. Since that time, we've taken some of our learnings from the world of video surveillance and applied them to other applications like virtual desktop infrastructure, like backup and disaster recovery, general purpose data center infrastructure. But the heritage of this business and the primary focus of it today and going forward is IP video surveillance, and that's what we're going to talk about today. We are deployed in over 53 countries around the world in virtually every type of end-user vertical or end-user industry. We are trusted by some of the largest and most well-known names in the world, not just in the United States, but really all over the world. Okay, so let's talk about what hyper-converged infrastructure is, how it works, and let's look at how Pivot3 has done this now in a way that is purpose-built for video surveillance and what that means to us. So when we talk about hyper-converged, we start with standard off-the-shelf x86 server hardware, the same hardware that we showed you that we called before direct attached storage. The difference now is that these are typically deployed in arrays or in clusters of anywhere from 3 to 12 nodes together, and each one of those nodes will have some specialized software on it that effectively turns it into almost a little miniature data center. So that software does a couple of things for us. First of all, it virtualizes the servers and the server applications. So these could be video management servers. Primarily they're video management servers. They could also be things like access control, visitor management, or really any type of server application. We virtualize them, and now we can consolidate onto a smaller hardware footprint. Secondly, the software then extracts all of the storage resources, and I'll show you what this looks like in a little more detail in a minute, but it extracts all of the storage resources from all of the nodes, and it pools it all together to create a single pool of shared storage that we call a virtual SAN. The benefit of having a virtual SAN now is that all of the storage resources and all of the caching, which I'll talk about in a minute, is now available and accessible by every single camera and every single virtual machine or every single video management application on the entire cluster, regardless of which physical machine they're directly associated with. And that brings some real benefits, which I'll talk about here. So far, we've talked about the servers and the storage piece of it. I also want to introduce the client side of this. We also now have solutions that help you, enable you to virtualize the client access to these systems. And I'll talk a little bit later about why that is important and what kind of benefit that brings. Overall, the overall benefits here are a couple of things. First of all, we achieve and sustain the highest levels of performance. In video surveillance, performance is measured in throughput and in the amount of frames that are dropped. So we achieve the highest level of performance without dropping any frames, even when operating in what we call a degraded mode. Secondly, is we provide the highest level of data protection or the highest level of system resiliency, meaning we eliminate downtime, we eliminate data loss, and we ensure that you always have access to both live and recorded video, even in the event of failures. And I'll talk about that a little bit more as well. We're highly scalable. We can grow to multiple petabytes of size from a storage perspective. We provide fully effective, fully functional mobile solutions. And perhaps most importantly with all of this, we can provide all of this really enterprise-class infrastructure, all this enterprise-class value in a way that's highly simplified, that does not require advanced IT skills either to deploy or to administer on a daily basis going forward. So we'll take a look, a little bit closer look now at each one of the key benefits, starting with performance. So our Surveillance Series appliances leverage both hardware and software features now to achieve what I mentioned before is really the highest levels of throughput without any data loss, preventing video loss and negative impact on image quality. The way that this works is each one of these vertical bars would represent a node or a box, right? And we'll have the virtual machines or the servers running on it, and they're running inside of what's called a hypervisor. The hypervisor, if you're not familiar, is this piece of software that enables that server virtualization. The virtual SAN that I referred to on the previous slide has a couple of components. The software actually aggregates together a combination of solid-state hard drives, of RAM, and of traditional mechanical hard drives, and all of the networking bandwidth on the back end. And it creates this virtual SAN that is now specifically optimized for write-intensive applications like video surveillance. Secondly, if you're at all familiar with server virtualization, you'll know that in most cases it's actually not recommended to install video management applications in a virtual environment. And the reason for that is that the process of writing data from the VMS software to the disk has to go through that hypervisor layer that's in there. And that process actually imposes a performance tax of anywhere from 30 to 40%, which is really not acceptable in a write-intensive application like video surveillance. We eliminate that. Our software enables the VMs to bypass the hypervisor and write directly to disk and enable virtualized server environments without any type of performance impact. The ultimate result of this is very high levels of throughput that are sustained even during failure situations. Next is resiliency, or data protection. Most of you are probably familiar with a concept called RAID. RAID is a technology that's been around for a long time. Effectively what it does is protect data against the loss of either one or two hard drives simultaneously. We actually don't use RAID. We believe RAID is a bit of an aging technology. We use something much more modern called erasure coding. And our version of erasure coding is called scalar erasure coding, which is a patented solution for Pivot3. And what this really means to you is a couple of things. First of all, we can protect data against the loss of up to 5 drives simultaneously, or an entire node, meaning an entire box, and all 16 hard drives inside of it, plus 2 additional drives elsewhere in the cluster. If all of that is lost or fails simultaneously, completely fails, I mean the power cord unplugged or whatever happens, completely fails, not only is the data protected, but it remains immediately, instantaneously available. So if we really provide a much higher level of fault tolerance against failures, we reduce the amount of time it takes to rebuild, and we maintain our performance even during those failure scenarios. Secondly, to ensure system uptime, we have server failover automatically directly built into our solution. So in the event of the loss or the failure of one box, the virtual servers on that box will automatically move and restart somewhere else inside of the cluster with no user intervention required. The important thing to note about this is not an option. This is not an additional piece of software. There's no additional cost for this. There's no need for additional licensing. It's automatically built in to all of our solutions. And finally, we do something called predictive failures, which basically means we constantly monitor all components of the system, particularly the hard drives, and we look for things that are about to fail. And when we find those, we automatically, logically remove them from the system and replace them to prevent the potential for any data loss or any impact on overall performance. The result of all of this is really, truly enterprise-class resiliency, 6 nines of uptime and availability. Now, as I said before, all of this sounds complex. It sounds great, but it also sounds like we need a PhD to deploy it and to manage it, and that's not true. In fact, we have designed all of the complexity out of this enterprise-class infrastructure. We have very simple point-and-click interface. Virtually all of the tasks that are typically managed by a person have been automated. This is a self-managing, self-optimizing, self-healing, and self-monitoring solution. And if your IT departments and your end users use tools such as VMware vCenter to manage their IT environments, our solutions easily integrate directly into that so that they can be managed with the same tools that your end users are familiar with on a daily basis. I want to talk for just a second about scalability, because this is an important concept to understand. As needs change and we need to scale systems up, or as we call it, scaling them out, in the world of video, it's important to understand that it's not only storage that has to be scaled, but it's also performance, or what we call compute capacity or throughput. As we add nodes into an array or into a cluster, we scale both storage and throughput capacity simultaneously. And the more nodes that are in a cluster, the higher the level of overall throughput available to every single camera, regardless of which physical machine they're associated with. This is very different from the way that traditional NVR or direct attached storage infrastructure works. NVR, as you scale an NVR system out, it's represented by this red line here. What actually happens is you scale out the total amount of storage, but you really don't scale the throughput capacity through. All you do is put another system right next to the ones that are already there. So you get a constant level of throughput as far as the camera is concerned, the end camera is concerned, but a growing level of storage. So very different scaling out the Pivot3 solutions versus a traditional NVR-based infrastructure. The last concept that I'll talk about here real quickly is mobility. I told you that we have a new solution called the Virtual Security Server that enables us now to virtualize access to the client applications or the client workstations. And this does a couple of things. It eliminates the need for very high-end, very expensive graphics workstations. It also enables you to deliver now fully functional, rich client access, even with integrated systems, to any type of mobile device or any type of endpoint device, whether that's a mobile device, something called a zero client, which is effectively a very low-cost replacement for a workstation, or even drive things like entire video walls for a fraction of the cost of before. Now, to enable this, we leverage a technology called virtual desktop infrastructure. The problem with virtual desktop infrastructure traditionally is that it doesn't work very well for video surveillance. It's becoming very, very popular in the world of IT for lowering costs and making things simpler. It doesn't work very well for video surveillance. We have solved that problem. We now have a virtual desktop infrastructure solution that is optimized directly for video surveillance. And we can deliver conservatively 40 simultaneous 1080p 30 frame per second video streams from a single virtual security server node. And in actual deployments, we're getting more like 60 to 65 simultaneous video streams off of a single node. So what's interesting about this is that the only thing that is actually delivered to the endpoint device is the image of the desktop. The data itself remains inside the data center, never leaves the data center. What that means, it remains secure. It remains protected. We prevent somebody from downloading sensitive video data and uploading it now to YouTube or to some other place where it's uncontrolled. So the virtual security server enables you to effectively recreate a security operations center environment anywhere on any type of device at any time. So this is just a recap of what we've talked about already. I won't go through all the details. The list of features that we have is on the left-hand side. I do want to point out one thing at the bottom there, and that is our deep domain expertise in the world of video surveillance. We don't just understand server and storage technology, but we understand the entire ecosystem and all of the things that go into making a large-scale or a critical video surveillance system operate effectively. Our solutions are designed to prevent data loss, to maximize uptime and availability, to scale effectively and efficiently, and of course, to reduce overall costs and complexity. I just want to wrap up here because we have a predominantly security integrator audience here. I want to talk a little bit for a second about our new revamped partner program. We're calling it the Pivot3 Partner Program. It's not the most creative name in the world, but really it's here now to been completely revamped, completely overhauled. Really, it's here to make your lives easier, to make it enable you to market, to sell, to install, to implement, and to manage our solutions for your customers in a way that is seamless, that is simple, and that works well for everyone. So I encourage you to reach out to us separately to inquire more about the revamped Pivot3 Partner Program. I think we have some information here on our website now, but we're always available to talk to you in more depth about what we're doing there. And with that, Scott, I think that comes to the end of my presentation. I'll turn it back over and see if we have any questions.
Great. Thank you so much, Brandon. That's right. If you have questions, we have some that have come in during the webcast, but we'll be on for a few more minutes, so there's still time to send some in if you're so inclined. Right now, looking at what we have, Brandon, how do you manage throughput, or what is the maximum throughput?
Yeah, good question. So the maximum throughput is a number that will fluctuate depending on a number of different variables. So it'll depend on the VMS. It'll depend on exactly what the configuration looks like. Generally, we talk about in a 12-node array that processed video ingest. And what that means is the amount of video that we can ingest or take in and write with zero loss of frames, zero frame loss, will be roughly north of about 7 gigabits per second. And what's important to note is the zero frame loss, and is also that we maintain those high levels even in degraded modes. Now, again, some of this will depend on what the network infrastructure looks like. This will depend on how many cameras are out there, obviously, and what the VMS is. But we do design to the highest levels of performance to ensure that we achieve really the highest levels of throughput in the industry and sustain those even when things start going bad.
Brandon, what about comparing network-attached storage for video surveillance to SAN? What are the benefits or drawbacks there?
Yeah, that's a good question. There is a definite difference, besides just the spelling, between SAN, which is Storage Area Network, and NAS, which is Network Attached Storage. Even though it sounds like the same thing, both of them are shared pools of storage that can be accessed by a server application, but there's a very, very different underlying architecture to them. In fact, so different that NAS storage is generally never recommended for video surveillance. And the reason for that is it is what's called a file-based architecture. Actually has a file system. So as data comes into it, it has a file system that groups all that data into files and then stores it onto disks. That overhead, or that process, that file system adds significant overhead to a NAS solution. And therefore, it will perform very, very poorly for write-intensive applications like video surveillance. So, NAS is really built as a file server, or as maybe a backup or an archive type of storage solution. Does not work well at all as a primary storage medium for video surveillance. SAN is different. SAN works extremely well for that.
Thanks, Brandon. What about virtualized clients? How are they different from normal VMS clients?
Yeah, so that's a good question. So when you talk about VMS clients, there's a couple of different elements of it. One, there's the software. There's the client software that typically is installed on a workstation somewhere, and that's what we call a rich client or a full client. Then we have mobile apps. Most VMS manufacturers have a mobile app of some sort that enables you to look at video on a mobile device. And some of them have now web apps as well, so you can access all this through a browser type of interface. All of these have benefits and drawbacks to them. Typically, the rich client is the most fully featured and fully functional. It allows you to look at live or recorded video. It allows you to look at any systems that are integrated, like access control or visitor management or alarm management, whatever it happens to be. The problem with that is that you need kind of a high-end, expensive, graphics-enabled workstation, and you generally have to be either on-premise or inside of a security operations center or something like that to use it. The web apps and the mobile apps usually are much more limited in functionality. And in case of a mobile app, oftentimes you'll get maybe 4 or 5 maximum cameras that you can look at, and usually in live only, or maybe some element of recorded video. But you can't look at anything in great scale, and you can't oftentimes look at any type of integrated systems. And how well these apps work are questionable. So with the virtualized clients, what we do is we kind of take the best of both. We enable fully functional, rich client solutions. So we deliver a full Windows desktop with the full client software and any other integrated systems. We can deliver that now to any device. We can deliver it to a mobile device. We can deliver it to a zero client. We enable you to mobilize a fully functional a fully functional client workstation, and we enable you to eliminate the need to buy high-end graphics-enabled workstations.
Excellent. Thank you for that. Brandon, another question that came in is, does Pivot3 have a list of manufacturers for VMS that have been certified?
Yes, we do, and we can certainly take that offline and provide you that list. If there's one in particular that someone's interested in, we can talk through that. Just so we know, just so everyone understands, our solutions are completely open, meaning that there's no custom integration that's required to get a Pivot3 solution to work with a particular VMS, as long as the VMS will run in a virtualized environment, which all of them technically will. Most of them are recommended they don't, but they all will, and on an x86 architecture. Then they'll work with Pivot3. We have gone through the official VMS certifications with most of the big VMS applications that are out there. We've done more informal testing with virtually all of the other ones that are out there, and we have actual customer deployments with virtually all of them. So we can provide that if there's any in particular that they're interested in seeing.
I wonder, how do you overcome limitations, with all the VMS companies recommending that servers should not be virtualized?
Yeah, that's a good question. It's a challenge that we deal with on a day-in, day-out basis, and there's a couple ways we do that. One is we work very closely with the VMS companies to educate them actually on what's happening in the world of server and storage infrastructure, and help them understand, what new solutions are available and how this actually impacts what they recommend to their partners and to their customers when it comes to the hardware piece of it. We also run constant testing inside of our own labs. And really this is more validation testing than certification testing. But we'll run testing with all the various, or most of the various VMS developers, and run them under different scenarios with different configurations and different optimizations and all kinds of different environments to ensure that the solutions will not only work, but they'll provide the level of performance and the level of resiliency that we do provide, and that in many cases we will actually guarantee that level of performance. So it's a constant battle that we face, but we find ourselves in the position of not only evangelists, but actually educating the VMS guys on what's happening in the world of server and storage infrastructure.
Let's talk a bit about failover. What is the difference between how Pivot3 sees that versus that provided by VMS software?
Yeah, sure. So typically in the world of IT, when they talk about failover, what they mean is failover of the virtual machines or the virtual servers. So if we run into a hardware failure, we have to move or restart a virtual machine somewhere else inside of a cluster to make it work. Now, there's some key differences. A lot of people are familiar with VMS or software failover, which it basically provides a second or a redundant recorder out there somewhere that takes over in the event of one recorder failing. Pivot3 failover can be used in replace of or in complement of, in conjunction to, software-based failover. You can use both. The advantage of software failover is the recognition if the app itself fails. But the challenge with software failover is a couple of things. Number one, if there's a full hardware failure, we can restart the VMS application in another place. They can restart it in another place. But they will lose access to any previously recorded video, number one. And they don't offer any protection for any other application that might be running on that machine, like access control or visitor management or whatever it might be. So the data loss is probably the bigger challenge, but the higher level of resiliency is different. So with Pivot3 failover, we provide that failover protection for the entire suite, for every single application that's running, and we ensure that during the failover process, when something has failed, that any previously recorded video associated with that server is still immediately available and accessible. And of course, as I mentioned before, there's a difference when it comes to software failover. You have to buy the software. Usually that's a paid feature, as well as the additional licensing and redundant hardware, extra redundant hardware that most of the time sits out there just idle, not doing anything, unless a failure occurs. In our case, there's no need for any additional hardware, software, there's no need for any additional licensing. And all of the hardware, we don't use redundant hardware, but all of the hardware in the array or in the cluster is used at all times. So all of the storage resources, all the bandwidth, all the compute capacity is being used, even if the VM or the virtual machine has not failed over to it yet. So it's a much more efficient, much more cost-effective way of doing failover.
Excellent. Thank you, Brandon. I'd like to remind everybody, if you have any further questions or something comes to mind after the webcast, feel free to reach out to Brandon, Pivot3, or Security Solutions Integration. And with that, we sincerely hope you enjoyed today's webinar. I want to again thank Brandon for sharing his keen insight on this critical video management topic. I want to also again thank our sponsor, Pivot3. As a reminder, an archive of this webinar will be available through the Security Solutions Integration website at securitysales.com. And be sure to check back often with SSI for new upcoming webinars. Lastly, to help us provide you with the very best possible presentations, please complete the short survey at the end of today's webcast. Thank you again, and have a great day.